grants, you're supposed to, both in the review process and in the writing process, and grant progress reports, you have to talk about reproducibility in science. There's crisis of, are scientific results reproducible? This is largely, we think of this in terms of experiments. Is the antibody any good? If you buy the antibody from this company versus that company, or today versus tomorrow, are you getting the same experimental result, quality of, are the cell lines what they say they are, and sometimes they're not what they say they are. People may know about HeLa cells in the 60s, 70s, and 80s. Sometimes people thought they were working on some kidney cell line, and it turned out it was HeLa cells because they got contaminated. So all sorts of checks like that. And I think what we're going to talk about is in computational work, how do we think about that, and what should we do? All right.
Sounds pretty good to me. You've pretty much done it already.
Yes.
Well done.
That's all I know about reproducibility.
Well, let's hope you know a little more afterwards then.
You can repeat what you just said.
All right, so good morning, everyone. So what I thought, as Roland pointed out, this is supposed to be a discussion. But let me just give a little context. And of course, everybody has their own view on what this means. I'll give you a view. So indeed, this is a discussion. But also the real work comes this afternoon around 2 p.m. because we're actually going to put some of this into practice. So Fergus Star 2 is here. And they're both going to sort of walk you through an interactive demonstration of some things related to machine learning, but also Jupyter notebooks and that kind of thing. So I'll try and remember to put this up at the end. Fergus, is you here? Oh, one. Okay. 1 out of 2. All right, so that'll go on this afternoon. I think that'll be very interesting. If you're not familiar with these tools, I think you'll find it really interesting. So why all the fuss about some of this stuff? And Roland's began to allude to it, but let me just sort of dig down. So I'll give you just a few minutes of context, then I have a few questions that we can address, but you can also bring up your own questions. I should say that we've 3D-SIG each year, we've done this kind of meeting, and we persist with it because I want to perhaps, but also that I think it's been reasonably useful. We did one on the relationship with machine learning and structural bioinformatics and so forth last year, and I think that got a lot of people thinking. And then, of course, there's a lot more content related to that kind of thing this year. And based on the role I used to have, where as the Chief Data Officer for National Institutes of Health, I can tell you that this notion of reproducibility is becoming more and more evident. And I'll mention that briefly and the motivation for that. So let me start with that. So this is, some of you probably saw this. This is what got things kicked off a number of years ago, back in 2012, with this paper that was published that basically the pharma industry said that 47 of 53 landmark publications in cancer biology could not be replicated, or could not be reproduced. We'll talk about replication versus reproducibility in a second. And then that led to a whole flurry of other sorts of activities, by which time, or concerns, by which time I was actually at the NIH, and we used to have, in the leadership at NIH, we'd have these meetings discussing this, because you can imagine, it doesn't matter if you're from another country, the principle is the same. If someone, a senator or some politician is sitting there and opens the morning newspaper, in our case the Washington Post, and reads that 47 of 53 expensive cancer studies could not be reproduced, they suddenly start asking themselves, what on earth are they doing over there at the NIH if this is the case? Why are we giving them $34 billion a year if they can't reproduce this work? This has enormous, and that person happens to be on the appropriations committee for the government. That has enormous ramifications. So, and that trickles down to certainly all of you in the US, but the equivalent sort of situation goes on around the world. So this is something that, at least from the point of view of the funders, and I'll give you some other perspectives in a minute, clearly has significant impact. So what's the sort of causality of all of this? How does this come about? And there's lots of reasons. There are lots of cases where people are cherry-picking data. There's the misapplication of black box software, which leads to issues. These are more geared towards work that we do, which is in silico as much, if not more, than experimental. Poor bias in the way we approach problems, poor positive and negative controls, improper statistical analysis, and many other things. These are many things that are not caught out by the peer review process, which itself is under some level of threat right now, so which I'm not necessarily going to go into. So it's kind of useful to look at these issues through the eyes of different stakeholders, and I sort of did that a moment ago from the point of view of the funders. And so let me start with that again, just to build on that. So what's the reaction to the kind of thing I just described with a threat on the funding for an agency? Well, they obviously respond to it in different ways, but the kind of things you'll see are new policies that actually relate to aspects. So, for example, the NIH has now instigated data management plans. They used to be just on large grants, over $500,000 a year direct. They are now implementing data management plans on all grants. So you have to essentially be able to show, and until recently, that has not really been part of the review process. But now you actually have to show and prove that the data that you're producing from that study is A, available, and B, it's accessible and it's in a form that can be reused. And the NIH now talks a lot about something that myself and a whole bunch of people who are interested in scholarly communication have been involved in for quite some time, which is the so-called FAIR principles, which is this notion of being able to find, access, interoperate, and reuse data. And it's floating around this meeting a fair bit as well. The NIH is totally behind that now, and you're going to see ramifications of that. So what you'll see over time, in my estimation, and as I was involved in these things, I think there's a good likelihood that these things will happen. I'm just not making this up. Is the idea is that they will actually check what you say in your data management plan. So if you say you're going to put data X on repository Y on day Z they're going to look into repository Y and see if X is in there. If it's not, questions are going to be asked. So it's closing that loop. They can't do that right now because it's totally manual. But it's rather ironic that data itself goes into these repositories. When you publish a paper, you wouldn't dream of not putting the funding agency, the grant numbers on it. That's going to start being on data as well. So that actually then adds to the idea of reproducibility because the data is actually going to be accessible. So that's just a funder perspective. Some publishers are also on this bandwagon. PLOS, for example, which I'm heavily involved with. In fact, I chair the data committee for PLOS computational biology. You actually have to make that data available for your paper to be published. So that's another example of trying to facilitate reproducibility by making data, and actually applies to the analytics as well. And so that's the sort of funder response. Do they have good ways of checking that? No. But do reviewers spend a lot of time looking in to see whether that's the case? No. But there's growing tension around this. And then, of course, the public itself is the value of science is under, at least in this country, under fairly serious threat right now. And the notion of being not able to reproduce science actually has a lot of effect. And then from your point of view, as researchers, and mine for that matter, sort of reproducibility is a bit like broccoli, I think. No one wants to eat it, but you know you need to if it's going to, because it's good for the research of others, and ultimately it's going to be good for you because it's going to define whether you get money or not. So that's sort of where we're at. Some terminology around this. That's the sort of view from different stakeholders, from my perspective at least. Some terminology around this. I think if you have the same data and the same software, that in principle is reproducibility. But of course, as we all know, that doesn't happen very often because you often have no control over the data that you're using. The data, for example, from a public database could be updated. So by the time you come to repeat a study or build off an existing study, all you can do at that point is replicate because the data has changed slightly. Does that really matter? No, not from my point of view. As long as you are convinced that the process that you're adopting out of the former work indeed is working. And then you can look at the other sides of the quadrants as well. Same data, different software. That implies that the data, and you get if you get robust results, that would imply that certainly the data is probably good data, well-defined, good metadata, and so forth. And then different data and different software means you can generalize the whole process, which also, of course, is not a bad thing. But as we know, it's a lot more complicated than that. The infrastructure changes, hardware, compilers, libraries, languages, etc. change. And then the process that you might adopt is different than... it's very rare that you could actually complete a study that someone else has done by reading the material and methods section of their paper. There's just not enough information in there to enable you to reproduce the study. And so you either do something a little different, or indeed, you basically have to reach out to the authors, which of course we do all the time. I think 3D-SIGers, as I will call ourselves, I think we do pretty well compared to other disciplines. But of course we could always do better. The history of the data that we use through the PDB and other repositories, I think actually speaks to a lot of this. The fact that the PDB has been an open and accessible repository licensed in such a way that anyone can use the data for any purpose. I don't know if it's actually stated now, but it's essentially CC0, so that it's, you don't even necessarily have to attribute, but of course they encourage you to attribute. And that, I think the fact that many years ago there was this, the community itself got together and said, we don't want any of you publishers to publish a paper unless the data associated with that structural paper is deposited in the PDB. You needed a PDB identifier to publish. That was, and still is, almost unprecedented across science. So it was actually a community driving people to make that data available, which of course facilitates reproducibility. And that's an example of a declaration. We're generally an open source community, very good things. Lots of standardization goes on through ontologies and just data formats. We have core facilities that support a lot of this stuff, and there's quite a lot of international coordination. I mean, it's amazing that the WWPDB is an international organization with Japan, Europe, and US, and it operates and makes consistent data under standardized principles. All of that's a really positive aspect. But having said all of that, if you look across, even within our own community, recently, well, a couple of years ago now, I guess, NLM did a study which is referenced here at the bottom. And what they did was they actually looked at 1 year of PubMed Central. And they went through every paper in PubMed Central, looked at the data sources that were described, and said, is that data publicly accessible? Only 12% of the data in those papers was actually accessible. So 88% was essentially dark data. It wasn't even available. You had to go back to the authors, and we know that that doesn't always work very well. And I'll give you an example of that from my own work in a second. So there's this issue which is attempting to be addressed by various people like GigaScience, and I'll say something about that in a second. I don't want to go on about this. We want to get to having a discussion. But I think there's definitely incentives to do this. So about, what is it now, oh my goodness, 5 years ago already, we did a paper. The title of it wasn't, but it could have been, I Cannot Reproduce the Work from My Own Lab. And you can laugh, but I guarantee you, I would almost guarantee you're in the same boat. All right? So we took an in silico study that was actually a tuberculous drugome piece of work, which was really finding the binding sites across the whole drugome, mapping that to FDA-approved drugs, and finding off targets and so forth. So that paper was published. Then we went back 2 years later to try and replicate the work. Well, you know the situation so well, right? So the idea was to take all of those pieces that we had and put it into a workflow system. It took us we measured various aspects of this. It took 280 hours to reproduce this stuff, okay? And I'm sitting there thinking about this, and I realized in, gosh, 40 years, sorry, I'm not that old. 40 years I've been doing this stuff or more. Nothing has changed. I remember My PI would say, go and reproduce so-and-so who's left the lab, go and do this, start by reproducing this piece of work and then we'll build on it from there kind of thing. And it was exactly the same thing is happening now. We've got all these new tools, all this new stuff, but it's the same thing. Why? Well, obvious reasons. The first author, well, the most obvious reason of all is I was the last author. I had no idea what was going on. Did I know where any of the data was? Did I know where the software was? Did I know where anyone kept the scripts? This kind of stuff. So clearly no. The first author, Sarah Kinnings, who did most of the work, she'd left the lab. Fortunately, she was just down the road at Synchronon, so we could actually, and she was very helpful. So she still had all this stuff. So gradually we repieced all this together. We measured each step of the way of what it took to recover each step of this in silico pipeline and put it into a workflow system. And as I said, 280 hours spent. Now, it's not that replicating people's work like that is not necessarily useful. I think you learn something from the process, but goodness me, there are lots of other things to learn as well. And we should be, in my view, doing a better job. So those are, I think, within your own lab, there are incentives. That's the point. But there's also disincentives. And here's just two reasons for it. First of all, publishing or perishing, until the system changes, which it's now starting to do for the reasons I described already, the incentives weren't necessarily there. But the incentive was to publish new stuff. Forget about what you've already done. And that's still quite true, of course, but it's not quite as true as it used to be. And this is pointed out, there's a very nice article by some big names in our field, well, not our field, but in the field of life sciences, including Howard Varmus, who was the former director of NIH, essentially saying we disincentivize, the system is seriously broken because it's hyper-competitive. And so, we don't get rewarded, the incentives aren't there. You're not rewarded for actually making your work able to be replicated. You're rewarded for doing all the brand new stuff. And that's a huge cost. If you think about those 280 hours and you multiply that by a number of investigators doing all this sort of stuff, that's a massive cost to research, which just says that the whole thing is incredibly inefficient. At least that's my view. Cameron Nealon, who's one of the big names in this sort of space in the scholarly communication community, came up with this very simple equation about, the interest in doing all this. There's a friction versus interest in doing it. We're all interested in being able to replicate work, but the friction for doing it is not just the incentive structure that I talked about, it's actually the tools. And part of that has to do with the fact that for a while there were, a large cadre of tools. There still are. We have our favorites. People use Galaxy a lot. They use, there are whole platforms like the Open Science Framework. So there's things like My Experiment, Taverna, workflow systems. There are different types of repositories. There's now Wikidata. There's also Zenodo. There's all of these choices, and really it disincentivizes people from actually, sort of funneling down onto a more simplified system. Until recently, now I think what we're starting to see is really an aggregation, and you'll hear much more about this afternoon when folks, when they give you some examples of things going on in Jupyter Notebooks and so on. I mean, I think we're actually at the cusp of something quite different by virtue of the aggregation around these tools that more and more labs are using, and we're getting more and more exchange. I'm involved in teaching data science students. Every single student starts by having boot camps in R and Python, and then using GitHub and Jupyter Notebooks to do all of their work. And that's now working pretty well. Is it the complete story? No, but it's actually a good start. So at some point I tried to do this sort of very coarse analysis of where we were doing well and where we weren't, certainly in the more general area of computational biology. And so the Swiss flag means that we're doing okay, we're kind of neutral. The skull and crossbones means we're doing really badly. I have to say that the authoring tools, that was before the likes of the tools that we have now. So like Jupyter Notebook. So that's, I think, definitely an improvement. But still, there's a big jump between having something in a Jupyter Notebook and actually putting a paper effectively in a PDF that gets published by a journal. So, and then of course, where we're doing well is we've got clapping hands. This is obviously a completely qualitative set of situations, and you could argue with it. And this was from a couple of years ago now, so things have got slightly better. So let's. The idea here is to have a discussion, and I guess we're going to need to use the mic. So, yeah. And I'm, you know, I don't know if you ever watch Monty Python. I'm sure many of you do. There's a wonderful scene in The Meaning to Life where the waiter gives out conversation cards. There's a couple having dinner and they're not talking to each other. And so he brings out a card that says Greek philosophers, you know, so they get to talk about Greek philosophers for 10 minutes. So I am now going to give you cards. They're not about Greek philosophers. Maybe we don't need the cards, but here, these are the sort of questions that we should be thinking about, at least from my perspective, and you can bring up all of your own. But let's sort of kick things off, and I'll just try and sort of control if there's no, you know, I'll hum a tune if there's no interaction. Yes.
One thing missing from the discussion, I think, is trust on existing tools that will be hanging around so that they merit the investment that you make in them. Unless you're thinking, well, I'm putting all this time and in 3 years, this system that I invested so much will be obsolete.
So that's a good point. So let me say, before I answer that, and I'll give you an opinion on it anyway, let me say why I'm doing this in the first place. I'm doing this session because I think this community, because it is a pretty close-knit community, could actually be one that actually makes a difference, all right? So let me give you so the idea would be, in a perfect world, that we would all come up with some ideas in this session that you would go away and implement in your labs or the labs that you belong to. I know, I live in a dream world, but you know, that's sort of, so in the context of what you just said, here's a thought, and hopefully people got lots of other better ones. But why don't we have, let's say it's either a tool or it's a piece of data, it doesn't really matter. Why don't we have a sort of Yelp for that, or something where you know, there's a bit of a buzz on social media about tools that we use, particularly if they're lousy. But there isn't really a formal place that you could go and look. And so what happens, you know, you spend, I mean, I see this all the time in data science, right? They'll go and scrape a set of data off the web. Let's just say it's from the Department of Motor Vehicles, which is something we do, which is a joke in itself. Let's not go there. But you know, they work for a week trying to make something out of that data, just to try and wrangle it into some form, and they just give up. Then what happens? The next group comes along, instead of knowing what's gone before it and save that amount of time, they go and do exactly the same thing. And I've seen that actually happen in labs. I mean, you know, you get together for Friday evening beers, and a graduate student in one lab will say, oh my God, I spent ages with that data, blah, blah, blah. Oh, I've just spent this amount of time trying to do something with that data. So if we had a mechanism, it was a metadata about that data that included commentary that people have tried to use that public data set. I actually wanted this to happen in the PDB, but that was too controversial. But you know, that to me would be one answer to that. Maybe people have other answers.
Okay, thanks.
Don't be shy.
Yeah, I wanted to bring up something that I think you didn't, or you kind of glossed over a little bit, which is in addition to having these Jupyter notebooks, which clearly document what a person did, there's two other pieces that I think are important for reproducibility. One of them is when you write software, you mentioned that things like compilers and libraries change. But these days, I think you can wrap your software in a Docker container and sort of freeze it in Amber in a sense that you can run it. You can run that exact same version with the same libraries years later. The other thing is when you have a piece of data that was produced by some computational pipeline, you know, it's very important then to keep track of exactly, if you ran it from, if you got it from one of these Docker containers, what went in and exactly what went out. So that, in other words, this data provenance has to be very carefully tracked. And I wanted to point out that the DOE has actually made some really good progress towards not completely solving this, but at least showing some progress. And there's something called the Department of Energy knowledge base. I don't know if any of y'all have used it. It's for our field, it's not particularly useful right now. It's mainly focused on microbial genome analysis and microbiome analysis, and in fact, there's a limitation on even putting human data into it, and so it's a little, there's limitations. But I think they're moving in the right direction, and what they've done is they've formalized the concept of wrapping software in apps, and it's fairly easy to make a new app and release it to the public for other people to use in their own workflows. And then when you produce data using one of these apps, it very carefully tracks the provenance in basically a Jupyter notebook, and so you can publish these Jupyter notebooks and other people can more reproducibly use your data. So I just wanted to bring that up.
No,
I have some thoughts about reviewing too, but I'll let somebody else talk.
I think those are both extremely important points, and the Docker container in particular I forgot to put in there because that's a critical piece of this.
Of course, we can move into a system in which you cannot publish if you cannot replicate immediately, and
well, the problem with that is that you're dealing with publishers who make lots of money. They want to keep making lots of money, so they don't want to stop you publishing your papers. They want to lower the barriers, not raise them.
So there are some more obstacles to absolute reproducibility. I agree that K-base that John Mark was talking about can go a long way, but like you pointed out, for example, human data might be problematic due to HIPAA requirements or any other kind of biomedical requirements. For example, in my lab, we put together a grant that has to do with the NIH PubMed data. NIH PubMed data is very hard to access. This is human data for which you actually have to write an IRB just to, get in the website. That's not an exaggeration. That's exactly what needs to be done. And and in IRB, you have to really put specifically what you want to do with it, and you never know what you want to do with the data before you actually get to it, right? You kind of have a very fuzzy idea. So that's one obstacle. Another obstacle, Rafi said, okay, if you can't reproduce it immediately, let's put a barrier up for publishing. Trouble is, with deep learning being such a strong effector now in our field, you really need a few Alienware machines in your lab to even start reproducing what someone else did, and it can take several weeks, a couple of weeks of GPU time, just to do it. And I think that that is becoming more and more prominent, and in that sense, we are now, as computational people, moving into the problems of reproducibility that have harangued the experimental people, the wet lab people, for a long time. If anybody here has any wet lab experience, you know that you have to mix your DNEM cocktail exactly right to get the cells to grow just that way to have that particular effect. It's a very fine point. And we kind of have these issues now, especially when deep learning is coming in. So I think we should, be considering that as well.
I think, they're good points. I think the first one, the IRB access to human subjects data is, again, a big hurdle. On the other hand, there are things that are happening addressing that, which, again, out of the serious need comes solutions. They may not just be commonly used. But they're getting there. So a couple of examples would be synthetic data. There are now availability of synthetic data sets that emulate populations pretty well for particular kind of conditions. I think that's a tiny subset of what people want to do right now, but those are sort of growing. And then there's the sort of different models for accessing data. It doesn't necessarily get around the IRB issue, but things like Pcori and PCORnet, where the data doesn't actually leave the institution from where it's being accessed. What leaves in anonymized form is the output of the computation or whatever it is was done on it, which is not ideal either, typically, because as we know, all this stuff is always sort of iterative. But and then you have to deal with different APIs in different places and all this kind of stuff. So yes, these are the big problems, and likewise with the deep learning issue you raised. I don't have a good answer to that, but I think things will come that address these over time. Lots of input. This is great. Go.
I've stolen the microphone. I was going to say, I think there's one thing that was missing from the pressures on this, which is there is growing pressure, certainly in the UK, but I think around the world, for academics to be more engaged with the commercial system and work and commercialise what they do. And of course, if you make your research completely open, reproducible in that way, you have a lot of people who don't want to do that because it removes the possibilities that they're hoping for in terms of commercialization, because they also need to publish. So there are lots of pieces around that. I very much doubt that publishers are ever going to force pharmaceutical companies to publish only in a manner which allows us to exactly replicate their papers, because they don't currently at all. But also it's a pressure on academics to think about when they're publishing that people don't necessarily want to be open and reproducible because it causes them issues in other pressures that the funding bodies are putting on. And I think it's important because it's a real pressure in two directions. Make it completely open, but raise money from industry at the same time. And that's a non-trivial thing to do for anybody in this room.
Yeah, I mean, those are good points. I should say that these are unsolved problems because I actually pointed out when I was at the NIH that the data sharing policies that were in place were actually in conflict with what's called the Bayh-Dole Act in the US, which is essentially the commercialization of academic research, which of course includes data. So how do, no one at the Office of Science Policy really knew how to deal with that. So I suspect that's still true. But in any case, yeah, I think on the other hand, I'd also say that there is a growing realization in industry of changing the barrier to where what's commerciable and what's not commercial. So they're also realizing that there's a certain value to have some things. I'm thinking particularly the pharma industry, to have a certain.
SGC without Edwards.
I'm sorry.
The SGC without Edwards.
Yeah, exactly. So anyway, so I think the landscape is changing, but the point you're making is definitely really valid.
The Wikipedia model, of course, works very well for maintaining the integrity of encyclopedia entries. I wonder if there's anything like that that could be done, maybe incentivize it to students to reproduce research done on available data that maybe could be pooled in some central site. Or
I think that, too, is a very valid type of exercise. We actually have, and I meant to raise this in a different session the other day, but we actually have a Wikimedian in residence in my institute who actually works with the whole institution, the whole university. So this is someone who's paid, actually partly out of my budget, partly out of the library, to essentially take, particularly we're focusing a lot on Wikidata, is to at least get that data into the community so then the community can do exactly the crowdsourcing you described. I think my prediction would be, and I'm wrong every time, but in 10 years, that is going to be the most important form of data for biomedical research, more so than where it resides now. It might still reside in specialized places that have done curation, but there'll be a version of it that's sitting available with Sparkle queries or whatever it is at the time across that whole landscape of data.
I wanted to bring up the question of how we can bring these kinds of discussions into an available platform using social media. So on Twitter there are many discussions, there are lots of websites where you can find bits and pieces of this kind of information, and as a lab we've been working hard to kind of figure out what those pieces of information are, but maybe something on the lines of a Slack channel that people can plug into. All the information is there. There are people discussing ongoing ideas of how to improve these kinds of access to these kinds of data, and to solve these problems on an ongoing discussion rather than simply like building on this kind of discussion here.
Well, I think that's...
I can comment on that 3D-SIG is becoming more than just a meeting and something that will go on throughout the year. It will have a Google Groups and Slack. Maybe it's also an interesting idea, but we hope for this kind of dynamics to emerge, and everyone who's here who consented for receiving further communications will be automatically added to this Google group in the near future.
That was actually my last point about what action we could actually take away from this meeting. So that would be, these are good things to do, and you know, these things, some things don't work, some things work. We found Slack channels work very well in particular communities. Maybe it'll work well here.
I don't know if we have standards for different kinds of studies and exactly what data ought to be archived and where and how. So, for instance, associate editor for PLOS Computational Biology, and we've had some MD simulation papers, and the journal has had a discussion amongst the editors of, okay, you want to publish an MD simulation in PLOS Computational Biology, what do you have to deposit as supplementary data or, you know, on GitHub or something to justify publication? Do you have to put just the parameters that you used and the program and the initial, you know, the starting structures that you kind of put together and maybe refined or something? Or do you have to actually deposit the MD simulation someplace? And there are very few MD simulations online that you can obtain. And so all this effort goes into MD simulations. And I would love to analyze 100, because I think, like a statistician, not a biophysicist, I would like to have 100 different simulations that I could analyze for this or that property. I can't get those. They're published. I could write to 100 people and try to get them, but how? And so for every kind of study we do, and I don't know how many we could classify, you know, how many ways we could classify the kinds of studies that we do in, say, structural biology or computational structural biology. What are the things that need to be deposited? Where should they be deposited? And, you know, the journal is trying to urge people to do certain things.
Yeah, I mean, I think I just think as you're describing that particular situation with the MD trajectories, it's sort of kind of the discussion they had around the PDB probably in around 1970, right? And when there's a critical mass of people who think this is valuable, you know, it's sort of, this is how it bubbles up from the community and happens, because there's a shared need for that. On the other hand, what we've got coming in the other direction right now is, you know, the desire to spend less money proliferating data resources all over the place. And so there's a tension in there. And I don't have good answers to what it should be, but you know, I don't know.
I think the journal's going to publish a kind of editorial on what PLOS CB thinks is a good standard for that particular kind of study.
I would say, you know, one of the things that happened with the data policy at PLOS was there was this expectation we lose a lot of authors, but the desire to publish in those journals was still strong enough, well, in PLOS Comp Bio at least, that it didn't actually, it goes across all PLOS journals, but certainly in PLOS Comp Bio, I don't think we saw a decrease in submissions because of it. It might have been a slight blip, but it came back up.
You have more questions?
Peter's, yeah, I have more questions. This is just number one.
In terms of what's missing, I think missing is also training. I think that's one problem why we have so little reproducibility, because, you know, graduate students come in, they don't know how to use GitHub, they don't know about versioning, etc., etc. So they really don't have any guidance how to set up a project so it's reproducible. And I think that's where the 3D-SIG could help. And I think there's something going on this afternoon, I don't know exactly. But having something more hands-on during the 3D-SIGs, like a hackathon type of, where, you know, people work together, learn from each other, you know, how to do this in a reproducible way.
You actually walked in a little late. We talked about that. It's at 2 o'clock. It's going to be fantastic. They promised me. And it'll be hands-on stuff. You know, there'll be flashing lights and everything.
So you have about 20 minutes. You might want to get to your
Oh,
other question.
okay. Thank you.
Thanks, Roland.
Actually, in
That's
some
what I was
ways, you're
trying to say.
answering.
That's my role as chair.
So this, in some ways, we've sort of begun to address some of these other things as well. But, I mean, do people feel like it's a real pain now? Presumably they do. And, you know, where do you see the balance? Do you feel, you know, if you ask yourself, if you look in the mirror and you say, I should be doing more in my lab or in the lab I'm in to be reproducible, is that what you know, can that happen? Can the needle shift? Where do you see the balance? We're setting up, I should say, we're setting up, the institute I'm setting up, we're actually setting up to be, the problem is when you've got something that's entrenched, changing it is very difficult. What we're trying to do as an example is really to incentivize by the fact that promotion and tenure is actually going to be partly dependent on where you place the needle for yourself. So the expectation is to be at least be able to people to replicate your work, and that's evidenced by sharing of the analytics that you produce, how you collaborate, where your data is deposited, and all that kind of stuff. That's actually going to be an active part of the review process, which is not the case almost anywhere right now.
I would worry if I put a lot of effort into depositing, annotating, making available, formatting, how much of it is ever going to be accessed? You know, we all publish papers, and sometimes papers are not cited very often. And you think, I did all that work and nobody has cited that paper. You could do the same thing with a lot of, data that you have curated, made available in ways that people can use it, and think, well, what are the chances that somebody's actually going to use this? How much effort do I need to put into it? That's, I think, one reason people don't do it is maybe nobody's going to need that particular piece of data or that particular format. It'd be a lot of work for nothing.
Yeah, no, that's very true. And then, of course, there's also the Sleeping Beauty situation where no one touches anything for a while, and you think, oh, I did all that work, and then suddenly, for whatever reason, there's interest. This happens with papers as well as data, of course.
But this concern of yours is mitigated a bit if you build from the ground up with a view on replicability or reproducibility.
While you're doing the work.
Yeah.
Let's hear from some people. The rest. I mean,
I'll throw the
myself and the
microphone
chairs
whoever
are
wants.
actually.
Hi, so I'll speak as an outsider to this community. I'm not in structural biology at all, but I'm part of a new center for reproducibility in biosimulation models. So things like biomodels.net. But yes, right, so that's why I'm here. So one thing our center is thinking about, and it's a new center, so I'm here to get information, not to tell you about our center, is, and this has to do with the potential gain to people. So I don't think we have a solution to the pain. It's always painful to document things. But the gain might be exactly this kind of Sleeping Beauty effect maybe, or something like that, because our notion is that there's a flood that no researcher can keep up with literature very well. And so if we have journals forcing everybody to have standardized annotations about both the data and the methods that you used, then that enables computational search engines to search not on keywords or free text or anything like that, but instead on the particulars of the method that you used. So I might be researcher A, and I happen to use method X with parameters Q, P, and R, and I want to know who else has used exactly those parameters on this methodology, and I don't even really care about the data set maybe. So suddenly, if you put in the extra work to sort of describe formally what you did and make that reproducible, then you might, the potential carrot we can offer researchers is saying, if you do this extra work, then other people will find your work more easily, and you will find others' work interestingly. So that's one idea our center has, and I'd be interested to hear if that resonates.
That resonates. You also made me think it's a little tangential, but we don't actually have good metrics for these things. And we have, the fact is, to Roland's point, we still publish those papers even even when they're not cited. But when that changes for whatever reason, the numbers are there to show the value through the citation networks and so on. We don't have bibliometrics for data, and that would be that are recognised by communities as being of value. That would help the situation as well.
Tenure cases, number of downloads of data.
Yeah, we have that, but it's not necessarily somewhere that forms a network that can be, or it's easily accessible necessarily in a generalized way. Altmetrics did quite a lot for papers in exactly the way you described. We need altmetrics for data as well.
So I'm a computational biologist, but before I started doing science, I was actually a software developer, and I was trained in rational unified process and in reading documentation and writing documentation. But when I started doing science, I realized that there was a big difference, and so there was not the incentive for documenting things. But more than that, it was actually when I wrote my paper, like the first trial. So somebody told me that it was very, like, with that spirit, like as a software developer, like trying to, because I tried to put every single detail there, like thinking that somebody could just read it as maybe as a user manual of how to use my software, or how to use my programs. So, but my thing is that I feel like maybe we should incorporate some things from software development like world of how to document things. Because I mean, they're very, I mean, there's a whole field for that on how to document things and how to, I know that it's different, like the type of things that we do here, but maybe some kind of intersection or some kind of point in the middle where we can use a lot of things that they have developed in the software development field.
Good point. I think, again, it's the incentives to do that. They're not there, as you pointed out yourself.
So I've got a couple of points. Basically, I'm the curator for GigaScience database. Now, when we publish stuff in GigaScience, we make sure all of the data is made available in GigaScience database. So that's one thing that we do on a regular basis. And we curate all of that information in terms of pulling out all those bits of information that are generally in the methods section or in the sample descriptions or whatever, and make it searchable via the database. So all the information is there. So we actually make things searchable. And one of the things that I struggle with from a field that I'm not familiar with, such as this one, is the standards to be able to know which bits of information I should be pulling out to actually put into the database. So having a repository or somewhere I can go to say what should be the standard of metadata, as it were, that I need to be collecting and forcing the authors to be providing would be useful. And the second point was about the Altmetrics style thing. So DataCite are now doing make data count. And that's something that we're looking at actually implementing on all our data sets as well, so we can actually have a similar sort of citation factor, as it were, for data. So I don't know if that's something that should be considered across other repositories as well.
I mean, I think you're undoubtedly leading the way in this, and I commend you for doing GigaScience for doing that. The first point you raised is I'm wondering how to best go away achieving that. I can imagine that, you know, it's getting editors that are willing to spend the time to actually help you identify that metadata. I mean, in structural biology, I think that would be relatively straightforward, at least, you know, a subset of things that will be of interest. And as you expand out from there, I think there's lots that could be had that I'm sure you're not getting, but with some expert advice could happen. So I'd be happy to talk to you about that offline, about how to try and help make that happen, I guess.
So I heard a good idea about setting up Google groups so that we can have a continuous discussion, and all the issues that have been raised, I think as stakeholders in this room, we can come up with standards through working groups or even through discussion through these Google groups over the year to sort of decide on what parameters to be searchable or what parameters to be deposited so that we can, going forward, sort of streamline that process.
Remind you of that when we get the groups going.
So maybe we go on to the third question, which is sort of, it'd be good to hear, particularly from people we haven't heard from, what is your lab, Ido, we'll let you say what you want to say in a second, but be thinking about post-Ido, what is anything that your lab could be, what is it doing to improve the situation, if anything, that we haven't already heard about? I mean, what protocols, what standards do you have in your own lab for doing this that might benefit other people in the room?
That we didn't discuss yet.
I'm sorry?
That we didn't discuss yet.
That we didn't discuss yet, absolutely.
Actually, I was kind of getting to that. So, kind of pre-post Ido kind of thing. An experience we had in my lab, basically, or with a collaborator who wrote a large part of the software in MATLAB, which is a proprietary language, and therefore, if you're not licensed to run MATLAB, you cannot reproduce things, you cannot put it in a Docker, right, and so on. There's a licensing involved here. And many labs use MATLAB, SAS, SPSS, proprietary languages to do their science. There's proprietary software in molecular dynamics, quantum mechanics that actually sue you if you try to reproduce work done on that software on the open source version of the software, which they keep suing because they deem it to be illegal. So like that would be like S suing R.
That's a whole different language. Seriously, there's this thing going on in that field. It's pretty horrible. Anyhow, getting back to the point, and going back to the pain and gain issue, we actually took the MATLAB software and rewrote everything from the ground in Python, to get that reproducibility, because it was part of an effort that we are doing in the critical function annotations to have everybody to be able to use our software, and they would not be able to do that if they don't have a MATLAB license. So that goes to two things. One, how we're improving the situation. Second, it's incredibly painful because we're just replicating stuff that should not have been done in the first place the way it was done.
Thank you for that big downer. We've got people who want to address the third question up the back.
So I was going to do the second and the third. So on the balance between pain and gain, I think that when my graduate students can reproduce their own work, that's kind of the bar I want to see as a kind of a minimum. Now, some of that work may never need reproducing by other people, but if they can't even reproduce their own work, I think there's kind of a problem with the way they're working, and I actually think that there will be a gain from them working in a way that allows them to reproduce their own work. Maybe going the extra mile and getting it to a point where someone completely outside the lab could reproduce it, that might be further work, and that might be where the pain starts to outweigh the gain in some cases. It depends how important the work is. In terms of what my lab's been doing, one of the things I've done is I've hired a computational scientist whose job it partly is to get the graduate students to help them get to that stage where they can reproduce their own work. So to help them organize their work in a way that will allow them to reproduce it, and to get them familiar with tools like GitHub and Git that they don't necessarily come into my lab knowing. And we've also, just as an advert, we've been working, I have another postdoc who's working on an R package that tries to make developing work in R through RMD files, making it more reproducible by integrating it with Git so that the version appears in the HTML file created. It's you could imagine something similar with IPython notebooks, but we focused on the R infrastructure because my lab is particularly involved in R. So if you're interested in a package along those lines that integrates RMD with Git and knitr, it's called Workflow R, and be happy to talk more about it.
So part of what we're doing here with a discussion group and so on, and Slack channel, whatever we put together, it should be essentially a sort of bringing all these potential tools to the attention of people through some central place.
So I think there was like a discussion about going through the pain and so on. I think we need a culture change, and then general culture change starts with the next generation of scientists. I am with NIH and IGMS. We released a program announcement about rigor and reproducibility. We are looking for training modules that people can use in the education arena. So if you have ideas about how to introduce rigor and reproducibility into the education of next generation of scientists, there's an RFA out there. If you do a simple search in IGMS RFA, rigor and reproducibility, you'll see the hit for that. So we are looking for short modules, anywhere from 5 to 25-minute videos that can be used for education purposes.
Great. So the gain there is definitely money to make some of this happen. So thank you.
Exactly, there's money in that. So we are funding that.
People are paying attention. No one was listening to what I was saying, but the moment you mentioned there was a funding opportunity, that everybody started going crazy.
Yeah, so an immediate gain that a funding agency can give is providing free compute power, which the DOE does. And so if the NIH did that too, that might incentivize people to use something. And of course, the pain is, taking away someone's funding if they don't deposit their data correctly. In my own lab, the benefits of reproducibility are not usually apparently obvious for a few years until then you have to go back and reproduce your own data. As you mentioned, it's, you know, it's not obvious that you can't do that unless you're careful at the beginning. So.
Okay, so we have a couple of minutes left. We've kind of covered this, but is there anything we haven't covered in terms of what we should do as a community? One part that I feel the current tools don't really help us enough with is really the project management aspect. And maybe I'm just not familiar enough with the tools, but you know, we still tend to use things like Basecamp and other, not Microsoft project, but just to maintain aspects of projects. And it's not necessarily something that people do in a research lab, but I'm just, you know, and certainly there are other tools like these frameworks, the Open Science Framework, and that give you some capability to do these sorts of things. But I'm just interested in that, and more generally in tools that people have found useful with respect to reproducibility or being able to replicate that we haven't touched on. Is there anything? Zero.
I think as an actionable item, the main thing here is to get from words to action, and perhaps as a community to start with continuing this discussion and building it in a understandable way with Google Groups or something else. Although this discussion is much bigger than just 3D-SIG, but we will start.
There are forums where these sorts of discussions sort of happen, but not particular to our community. And we can certainly link in relevant stuff. There's a group that I've been involved with for a number of years called Force 11, which is the future of research, communication, and e-scholarship, that look at these kinds of things on a broad scale. And it's amazing what other communities are doing, and say in the digital humanities and things like that, that actually can potentially translate to us in a very useful way. So we'll try and put some pointers of that in as well. So just to remind you, this is what's happening at 2 o'clock. Make sure you're here, it's going to be great. And is there any final words that people would like to have?
Can I just say something?
Anybody, including Rafi, yes, go ahead.
Anyone else but me?
No, go ahead.
Just start by getting every script and every software that you use in your next publication available publicly in a server that is not in your own lab. That's a good start already. You know, all data, all software, all scripts. It's a zero bar to.
Do we have, what's the mechanism for getting people aware of what we set up as a result of this session? Do we have email addresses, everybody in the room?
We will have a Google group with email address with communication capabilities for the people that allow that to happen. If they chose to allow ISMB to communicate with them. So
if
hopefully.
Not, feel free to send Rafi an email.
Yeah. Do so. I usually reply within 2 or 3 months maximum.
All right, well, I've had a lot of fun, so I can't tell whether you have or not. But anyway, thanks very much for your attention, and we'll move on to some things that we can't replicate. Thank you.